Hello everyone. In this video, you're going to learn how to use your TI calculator in order to be able to graph data sets. So, what we're going to use as our data set is data set 1 from the handout that you got in class. So, first thing we need to do is we need to enter in this data set into our calculator. To do that, we are going to use the Stat button. And in Stat, you can see it's on the Edit menu, and if we hit enter, we're brought to our lists. Now we are going to enter in this data exactly as it is into our list. So we're going to put volume in L1, and just to remind myself that volume is in L1, I'm going to write L1 right next to it. And then I'm going to enter in the data, so 0.1, 0.5, 1, 4, 5, 8, and 10. Now we can hit the arrow button to go over to L2, and L2 is where I'm going to put this pressure information. So let's write L2 right next to that to remind ourselves. And then we can start typing in the data. So 40, 8, 4, 1, 0.8, 0.5, oops. Those 0.5, 0.4, and always make sure that your columns are exactly the same length, otherwise you're going to get error messages. So now that we've got this into our calculator, we want to see what this graph looks like. So we have the y equals button, and you'll see written above it there's something called stat plot written in the same color as your second key. So hit that second key and then hit y equals, and you're brought to stat plot. So all of your plots should be off if this is the first time you've used this. If we go into plot 1 by hitting enter, you can hit enter again and turn plot 1 on. And that tells your calculator to look at your lists instead of looking at your y equals to plot some data. So the directions tell us that the first column is our x variable and the second column is our y variable. So that means that volume is our x variable, so we want to make sure that x list has L1. Pressure is our y variable, so we want to make sure that our y list has L2 in it, and that was in there anyway. So let's hit graph, and we don't see anything because our window is not correct. So by hitting zoom, we have a bunch of options. And if you go to 9, you can see that one is called zoom stat. So you can either scroll to it or you can hit the number 9. And this automatically changes the window of your calculator to fit whatever is in your stat plot. So you can see they're kind of small, but you can see our data points right there. Let's actually see if we can make them bigger. Let's go back in plot, and let's make these marks a little bit bigger so we can see them. There they are. Now what we're looking for is we're looking for a straight line with a positive slope, but this does not look like a straight line with a positive slope. So before we do anything else, let's sketch this really fast. So we want 0, 0 on our axes all the time. Our y-axis was pressure, measured in pascals. Our x-axis was volume, measured in cubic meters. And we can just do a rough sketch here. So, looking at our calculator, it looked something like this. Very clear that this is not a straight line with a positive slope. So we need to modify our data, or sorry, we need to modify our graph to show the data as a straight line with a positive slope. So if we can see, it looks like there's an asymptote on the x-axis and the y-axis. It's a pretty clear indication to us that this is an inverse relationship. So in order to make an inverse relationship straight, we are going to create a new graph. We're going to have our y-axis the same, but we are going to take those original x values, we're going to inverse them and put that on our x-axis instead. So how do we do that? How do we get the inverse of all of those volume data points. If we go back to stat, we can actually make the calculator do this for us. We don't have to manually re-enter in all of this data as 1 over 0.1, 1 over 0.5, 1 over 1. We can make the calculator do that for us by going to another list. If you go into the header of list 3, so you make the L3 highlighted, you can actually now type an equation in. So such as 1 over L1, and if you hit enter, all of those values are put in automatically. So if you take 1 divided by 0.1, you would get 10. 1 divided by 0.5 is 2. 1 divided by 1 is 1. 1 divided by 4 is 0.25. So now, when we try to replot this data, instead of having L1 as our X list, we can now put L3 in as our X list, and it should create a new graph for us. So let's hit graph, and there we go. We got something different. All right, so let's sketch this new graph. Remember, we did not change the y-axis, so pressure is still on the y-axis, but our x-axis is now 1 divided by volume, since we did that 1 over L1. And so since this has changed, it means our unit has changed. It's no longer cubic meters, it's now 1 over cubic meters. And if we look at that graph, it looks like a beautiful straight line with a positive slope. This is something that we can write a mathematical expression for. So let's use our calculator to get the slope and the y-intercept of this straight line. We're still going to use the stat button, but instead of hitting enter and going right into our list, you can scroll one menu over to calc, and you can see you have a bunch of new options. The fourth option is linreg, also known as linear regression. If we hit enter there, we then can type in the list that we use. L3 was our X list, and then put a comma in. L2 was our Y list. Now if we hit enter, the calculator is going to calculate for us our slope, which is 4, and our y-intercept, which is 0. It also gives you these statistical values. The most important one to look at is R squared. It tells you the correlation. So is this line close to your actual data? And 1 is the best result that we can get. We're usually looking for results that are somewhere between 0.95 and 1. So since we have 1 here, it means that we have a line that perfectly fits our data. So now when we write this mathematical expression, what we're going to do is it's going to take the same form as y equals mx plus b, but we're going to replace the y with what we had on our y-axis, so that would be pressure equals our m, which was 4, and the unit for that slope is the unit for your y divided by the unit of your x. So once we do, that would be pascals divided by 1 over cubic meters. That reduces to pascals times cubic meters. So that's the unit. Now we can do x. Our x-axis was 1 over volume. And then plus b, but since our b was 0, we can just leave it at that. And we're done.